Okay, so you should be on page 28 of the packet. You're going to see this pop up from time to time, which means you should just pause the video and try the problem that you see. So you can pause the video and try to get through the warm-up, then press play once you're ready. So for number 1, when you graph both of these lines, I see that -2 is my y-intercept. From there, my slope is 1/2, so I go up 1 over 2, up 1 over 2. And then at this point, you should have taken a straight edge and connected your points. I don't have a straight edge at home, so I'm gonna do my best. All right, then my other line, I have to go up to +4, and I have the same slope. Up 1 over 2, up 1 over 2. Then I should be able to connect my points. And again, connect my lines. So you can see that they never touch, which means if we're supposed to solve this by graphing, there's no solution. Because the solution comes from where the points intersect. All right. If you have not tried number 2 yet, you should try that now. All right, so I'm going to show my work for number 2. So I substitute in for x, -5y. Then this simplifies out to here. And I end up getting y equals -2. Y is my second point. So -2 goes here. And then when I solve for x, I get 10. All right, and then finally solve using the substitution method. Here's just the result for that. And that's your answers to the warm-up. All right, you can turn the page. Today we're going to be going over something called the elimination method. On other pages in this packet, you'll be able to see this is the steps for the elimination method. Our answers are going to be the same as they've been, which is it's always going to be x comma y. And you have this problem here. I rewrote it. You do not need to rewrite it. I just rewrote it so that you can keep seeing the original problem. All right, so step 1, line up the variables if they are not already. So my x is lined up with my x, my y is lined up with my y. Check the coefficients and signs and decide whether or not we should add or subtract. So we're going to use this to solve for the remaining variable. Basically what you want to do is you want to look at your x and your y's. And you want to see your coefficient is the number that's attached to the x or y. You want to see which numbers are most in common. Here it's my 2 x's, right? They're the exact same. So I want to eliminate this. And I'm either going to do this by adding or subtracting. If I add 2x plus 2x, that gives me 4x. They will not eliminate. But say I subtract these two. If I subtract these two, 2x minus 2x, that's 0x. 16y minus 6y, that's a positive 10y. Then 44 minus 14, that's 30. So you can see the x's ended up eliminating. So I'm left with positive 10y is equal to 30, which then becomes a pretty simple problem. Positive 10y equals 30. The way that we get rid of the 10 would be by dividing, making those cancel, and end up with y is equal to 3. I can go up here to where my solution goes, and for my y value, it's going to be 3. Just like the substitution method, we have to plug back our y into one of these two original equations to solve for x. It's not going to matter which one you choose. So I'm going to choose the bottom one. It would not have mattered which one we choose. 2x plus 6y equals 14. I just solved for the letter y. So instead of y, I'm plugging in 3. So instead of y, you plug in 3. From here, we just simplify out. The 2x stays the same. A positive 6 times 3 is a positive 18. Equals 14. From here, I would subtract 18 on both sides. I end up with 2x is equal to negative 4. Then finally, divide by 2. 2. And I end up with x is equal to negative 2. I go back up here to my equation box. And that's it. Solving by elimination. We're going to try more examples. But before that, let's go through this example problem number 2. Again, I've rewritten out this problem. You do not need to. I'm just doing it because I think it's going to help us if you can be able to see the original problem. All right, I'm looking for the variables that are similar. X has a 6 and a 2. And here it has a 5 and a negative 5. Now, those are the most similar, so we're going to be canceling our y's. So I have to figure out, am I going to add these or am I going to subtract these? Because the goal is that this ends up being 0y. The trick is on the other page, when it was 5x, or when it was 2x and 2x, we subtracted. The signs were the same, so we subtracted. But here, the signs are different. And if we want them to cancel, we actually have to add them. So, 6x plus 2x is 8x. If I end up doing 5y plus negative 5y, I get 0y. And then 10 plus 14, that's 24. My y's canceled out, which means I had 8x is equal to 24. I'll divide both sides by 8, and I get x is equal to 3. So I go my x blank equals 3. Now to solve for my y, I can choose either equation. It's not going to matter which one. I'll choose the top one for this time. And I'm plugging back my x value in to end up solving for my y. And that's it. We get a fraction, not the prettiest, but that's okay. Let me just check my work. Yep, we are good. So, down on the bottom, there's these two problems. You should pause the video at this point to try them on your own. Then unpause the video when you think you're ready. All right. Here, I see my x's are the same. So I decide that since one's negative and one's positive, I add them to make those x's cancel. 1y plus 3y is 4y. I already know my x's are going to cancel, so I can just leave that blank. And then 9 plus 3 is 12. Divide by 4, divide by 4. I get y is equal to 3. Then to figure out my x, I can go into either equation. I'll go into the bottom one for this. Instead of y, I should be plugging in 3. A lot of 3's here, which is fine. X is equal to negative 6. Should have been what you got. Negative 6 comma 3 is my answer. Then As for number 2, I see that my x's are about the same, but this time I'm going to subtract to cancel them. So this is where it gets a little bit tricky. 7x minus 7x, yeah, that's 0x. 3 minus negative 6 is a positive 9. 15 minus negative 3, that's a positive 18. Which leaves me with 9y is equal to 18. I divide by 9. Y is equal to 2. I take either of the original equations. I'll choose the top one for this one. And I'm going to plug in y is equal to 2. And I'm just going through solving for x. And again, one of our answers is going to be a fraction, which is fine. Leaving me with the answer. My x was 9/7. My y was 2. Alrighty. This next page. So you have problems on your Delta Math that look like this, and it's rather easy. All you're going to do is you're going to decide whether or not you add to eliminate x or add to eliminate y. So here, I have to think, am I adding to eliminate the x or am I adding to eliminate the y? Subtracting to eliminate x, subtracting to eliminate y. I notice my y's are the same. So I'm going to be eliminating the y's, but would I add or subtract to eliminate these? They're both positive. So for this one, since the signs are the same, I'm subtracting. Here, I know that I'm eliminating my x's, and again, since the signs are the same, I'm subtracting, but this time to eliminate the x. Number 5, my y's are the same. Here, my y's are the same again, but they're opposite signs, which means I'm going to add to eliminate the y. Number 7, my x's are about the same, and I have to add to eliminate my x's. Because when I add, since they're opposite signs, they'll eliminate. And then here, close. So these were opposite signs and we added. These are same signs. So we subtract. All right, and that's actually the entire lesson for today.